This project assignment on Smart Traffic Control System as instructed by Skyfi Lab Online Course has been completed by Anindita Paul, Ankita Kar, Arindam Paul, Mahashweta Saha and Ramanuj Chakraborty. In the next slides, we will show how the connections were made and the programming logic for the Arduino.
Smart traffic management systems are technology solutions that municipalities integrate into their traffic cabinets and intersections for fast, cost-effective improvements in safety and traffic flow on their city streets. Thus, this project was created by us in order to learn how the traffic system we see in our daily lives are implemented and how they are controlled depending on the traffic at real time.
The components used in this project were an Arduino Uno board, 4 IR sensors, male-to-male connectors, male-to-female connectors, an aluminum stand, a chloroplast board, a 180 ohm resistor, 4 red and 4 green LEDs, two connecting wires, one for connecting the resistor, the other connecting wire cut into parts is required for connecting the cathode of LEDs, breadboard, insulating tape, USB cable to connect to the Arduino for power and program upload, Arduino IDE, paper cutter, and toy cars.
Connections made in the traffic stand can be understood as follows. Number 1. The chloroplast was half cut in 4 parts to allow it to bend on the uncut side. On each part, red and green LEDs were attached by putting the anode on the left and cathode on the right side, and they were all marked as G1, G2, G3, G4 for green LEDs and R1, R2, R3 and R4 on red LEDs for lanes 1, 2, 3 and 4. Number 2. The terminals for the LED were bent on the cut side facing a direction, and the cathodes of all the LEDs were connected to each other with the help of connecting wires. These cathodes were thus connected to an 180 ohm resistor, which was later connected to the breadboard. Number 3. The anode on the other hand were connected through male to female connectors and male to male connectors to connect them to the pins of the Arduino board. The color of connecting wires for each LED was noted down in order to make sure there were no errors in the connection later. Number 4. All these connections or wires were made to pass through the aluminum stand on both sides. One side connecting the LEDs on the chloroplast and the other side had connections coming out to connect to the other components as described later. Last point, the chloroplast was bent with the LED part facing outside and the connections inside. It was made to resemble a traffic light stand.
Connections made to the other components were the connectors for anodes of LEDs that are previously noted down were connected to the pins number of Arduino as described. For the green LEDs, the G1, G2, G3 and G4 were connected to pins 0, 1, 2 and 3 respectively. The connectors for red LED R1, R2, R3 and R4 were connected to the pin number 4, 5, 6 and 7 respectively. The male to female connectors were used to connect each IO sensor to the Arduino board and the breadboard, whereas the female part of the connectors were connected to 5V, ground and D output or digital output of each IR sensor. The main part of the connector connected to the 5 poles was connected to the VCC end of the breadboard. The ground to ground end of the breadboard and the D out 1 was connected to the pins 8, 9, 10 and 11 for sensors 1, 2, 3 and 4 respectively. The resistor connected to the cathodes of the LEDs are grounded in the breadboard. Now male-to-male single pins was connected to the 5-volt and edge ground on the Arduino board to the breadboard, 5-volt to the VCC and ground on Arduino to ground on breadboard, one of which would be used for the resistor collector. Finally, after completing all the connections, the sensors were placed facing 4 different directions, and the toy cars are placed in front of them to deceive traffic. The Arduino was powered through the USB cable from the computer. Programming logic and code. As shown in the next slide is the program code for the working of the Arduino Uno board. The IR sensors were first initialized using INT data type as sensor 1, sensor 2, sensor 3 and sensor 4. The input for the 4 sensors will be saved in these variables. In the setup function we use the DDRD direction register for port D to declare all the digital pins we are using for the LEDs as output pins. Initially, all the pins are set to low by using port D. The indication made by the different sensors is input value for the variables sensor 1, sensor 2 and so on. These values was read by using the pins 8, 9, 10 and 11 on the Uno board and the command digital read which read the value 1 or 0 on these pins connected to the sensor. Now using if-else command, when the value of a certain sensor is 1 for its lane, the green LED for this lane was switched on and all other red LEDs were switched on as well. This was done using port D command for every lane with a heavy traffic. A delay of 2 seconds was given for the green light. If there is no heavy traffic on the road, we write an else function where we give a port D value for each lane and a delay of 1 second. The port D values for each lane in case of heavy traffic are as follows. Road 1 B11100001, for road 2 B11010010, road 3 B10110100, and road 4 B01111000. The logic of the values can be understood as shown in the table in this slide. Thus, on uploading this program logic onto the Arduino Uno board, the system works accordingly, giving us an efficient traffic control system. The understanding of this logic are as follows. In case 1, where the road 1 has heavy traffic, LEDs R1 is on, R2 on, R3 on, and R4 will be off, depicted by 0 and 1. G1 will be off, G2 off, G3 off, and G4 on, and so on as the table shows. Alongside, the program can be seen or the code can be seen to understand how the programming was done onto the Arduino Uno board. In case there is no heavy traffic on either of the lanes, the traffic light for each lane is set to high for green and low for its red, while others have a red as high. The delay of 1 second is given for each lane as shown in the code alongside. Thus, the IR sensor for each lane senses the heavy traffic and takes the value as input to pass it on to the Arduino, which instructs the traffic lights to switch on or off accordingly. This way, we can easily control the traffic lights in case of light or heavy traffic in real time. The working for the model or the traffic control system that we made can be understood as follows. The sensor for road 2 lights up in the first picture since there is a car in this road, whereas there are none on the other lanes, showing heavy traffic for road 2. The green light for road 2 lights up while the red for the other roads remain on to show where the traffic needs to be dispersed first. Similarly, in case of road 3, when there is heavy traffic, the green LED lights up after detecting the heavy traffic on road 3 by sensor 3 and
the red LEDs for other roads light up so as to diverse or disperse traffic in road 3 first. In this project assignment, we have learned how to use an Arduino Uno board to create systems for control and various models of daily life activities. We got to use the Arduino IDE platform to create the program for controlling the system and had the opportunity to understand the various library packages used in Arduino IDE. Thus, creating the smart traffic control system has led us to understand how such systems are implemented in our cities and how effective it is to ensure our safety and efficiency to control the traffic.